My dear students, welcome back to teleclasses. This is Rijuan PSK online classes. Slight change in the name, Rijuan PSK online classes. This is current electricity, the electrifying chapter. Last class we were talking about charging and discharging. Mobile phones discharges when we use that one. When we use that one, it discharges. Okay. Turn on the camera, the light, the flashlight, energy is lost from the battery in the form of light. It is lost, so the battery gets discharged. Now, when it discharges, we will take the charger and plug in here. The charger is an external source that will charge your cell. These are the ideas that we are going to discuss now. If I keep my display on, battery will discharge. That's why I turn it off. Okay, now it will not discharge much. Of course, there are activities inside that will eat battery. Last class, we discussed about what is the meaning of a cell. How does current flow in a cell? I told you outside it is going from positive to negative, but inside also it flows from negative to positive inside. Okay, I can say higher potential to lower potential outside the cell, inside the cell, lower potential to higher potential. When it flows outside here in the outer circuits, it loses energy, and here it gains energy. Chemical energy is converted into electrical energy. And I also told you about electromotive force and terminal voltage. Electromotive force is the potential difference between the terminals of the cell when it is an open circuit, and terminal voltage is the voltage across the same point when there is a current flowing. I told you that there is a voltmeter connected here, but for the time being, the current taken by voltmeter is not considered. It is negligibly small, very, very small. Compared to current taken here, the current taken here is 0. Comparing. Okay. So we can say even though there is a circuit here, there is no current taken. If you are smart, you will definitely ask, if there is no current taken, then how does it work? This is some basic assumptions that we make. Right. Now here there are two currents. One is taken by the voltmeter, another is taken by this circuit. I'm sorry. Where is it? Another taken by this circuit. Okay. Now this is neglected. The voltmeter current is neglected. So we will say there is no current taken here. There is a current taken by the circuit. Okay. This is said to be in the open circuit. This is said to be in the closed circuit. Okay. Done. Now, internal resistance. Internal resistance. I'll tell you what it is. See, this resistance connected from outside is called the external resistance, but the current flows through here, through the electrodes and the electrolytes. So the electrode and the electrolytes produces some resistance. The resistance to the flow of current offered by the electrodes and the electrolytes which are inside the cell, that's why we call it internal resistance. Internal resistance. Electrical resistance of the electrode and the electrolyte is called internal resistance. And the internal resistance depends, of course, on the nature of the electrode, the nature of the electrolyte, the type of the cell, everything. We have seen ordinary cells which are used in torch flashlights. These are known as dry cells, and they have a very high resistance because the electrolyte is not in an exact liquid form. But in the common electrolytic cells, this resistance is less. A fresh cell, a new cell which you bought recently from the shop has got low resistance, but as the cell ages, we use it more and more, unwanted chemicals will be accumulated inside, so the resistance will increase. It is always shown in series with the cell. I'll tell you what it is. Okay. So what are the factors affecting internal resistance? These are the different factors. Distance between the electrodes and the plates. Of course, when the distance increases, the resistance increases. Nature of the electrodes, which material, what is the size, what is the area, etc. Concentration of the electrolytes. When the concentration is more, resistance will be more. Nature of the electrolyte, which chemical it is, that is it, area of the plates. Okay. Also, this will depend on the temperature. Of course, you know the temperature will also affect this thing. Fine. So these are the different factors affecting internal resistance of a cell. Now, Now, see, I have a circuit where, when you get questions, you have to be very careful. When there is a cell given here, they will show E comma R. They will show E comma R, something like a 10 volt comma 1 ohm. 10 volt comma 1 ohm. What is that 1 ohm? Tell me. That 1 ohm is the internal resistance. Here R is the internal resistance. And what is this R? It is the external resistance. Okay, done? Now, how to use this in the circuit? When you want to calculate things, how to use, where to put it? Will it be put in parallel? Will it be put in series? Where is it put? That's what I said in the previous slide. It should be put in series, like this. So the cell, its EMF is shown. This is the internal resistance. And where is your cell? Where are the terminals? That's an important point. I think recently one student asked me, where are the terminals? In fact, you should know that in an ordinary dry cell is represented like there is one electrode here. You know, there is an electrode here and there is an electrode here. This is called the positive terminal. This is called as the negative terminal. And the connections are made here. One terminal here, one wire there, and one wire here. This is how you connect. Suppose that you want to connect this to a bulb. Let me draw a bulb. This is the bulb. And one wire go here and one wire go here. Now these wires are connected to the terminals here. So I can say this is one terminal, call it as T1. This is the other terminal, call it as T2. And where are this T1 and T2 in my diagram? Important point. See, this cell can create an EMF, a voltage, a potential difference, and this has got a resistance R. So both are inside. Both are inside. So in fact, the whole thing is your cell. The whole thing is your cell. That makes this terminal 1 and this one terminal 2. The terminals are one here, one here. Inside the terminal, what you have? The EMF as well as the internal resistance. So that is the way of understanding a circuit. So we can say this is in series with the EMF source. Now across the terminal, I have an external resistance connected. So where is this connected? Where is that connected? It is connected across the terminal. Okay. Let me clear this thing. Without those things, you should understand. Where are the terminals? Come on. Where are the terminals? The terminals, one terminal here, another terminal here, and that's where that is connected. Is that okay? Now let us go further. Is that okay? So there is one terminal here, there is one terminal here. I'll tell you once more. This is how the circuit will be given to you in the question paper. And this is how you should understand that one. And that is where you need to put the terminals. Where to put the terminal? The terminals must be put, be careful. Because why do I repeat such simple things again and again, you know? Because these simple things will cost high later if you don't understand it properly. Okay, so this is one terminal. It can be here or here because the potential here will be the same. So here or here. Any of this point on this wire is a terminal, is exactly like a terminal. Suppose I am asking you, connect a voltmeter in the circuit across the terminal of the battery. What to do, where to do? Connect a voltmeter. You don't have to put the voltmeter like this. This is not compulsory. This is okay. It is across the cell. But this is equally good. If you connect it here also, that is across the terminal. This voltmeter is across the terminal of your cell. It is also across the terminal of the resistor. So this voltmeter will measure potential difference between the terminal here, or it is also measuring potential difference across this one, because you know this wire has got the same potential throughout and this wire has got a common potential. You understood this? Oh, I'm sorry. This I didn't supposed to save it. I just wanted to clean it. Okay. Now let us go to the next point. You have a circuit. Tell me, where is the voltmeter connected? Where is the voltmeter connected? The voltmeter is now connected across the terminal of the cell. See, it is across the terminal. Is it across the resistor? It is not, because there is a switch here and the switch is open. So current cannot flow. I told you in the beginning, the current taken by voltmeter, never mind. That is negligibly small. Never mind. Assume it is 0. So current taken by voltmeter is 0. Can this resistor take any current? No, because the path is open. So open path means it cannot flow. Current cannot flow. I just want to tell you one more important point which can become useful later. What is it? If a circuit is open, if something is open, some part of the circuit is open, then resistance. How much is resistance? You know, resistance is infinity. At that open point, resistance is infinity because there is no current flowing. There is no current flowing, so we know R is equal to V by I. So I is equal to 0. So that is V by 0 will give you infinity. So that means if there is no current flowing somewhere, then the resistance is infinity. Okay, this should be kept in mind. So I am telling you, this voltmeter is connected across the terminal of the cell. So one point here, one point here. And there is no current flowing. Current through the voltmeter is neglected. So we can say no current flows here. No current flows from cell. That's important point. There is no current flowing from the cell. That means cell is open circuited. Cell is open circuited. Now when cell is open circuited, that will measure the voltage between this point and this point, these 2 points. And that voltage, the reading in this diagram, the reading of voltmeter, reading of voltmeter is called the EMF. The potential difference across the terminals of a cell when there is no current flowing is called electromotive force, EMF. This is the maximum voltage that cell can give you. Okay, that's important. Now what will happen if I close that circuit? Now see, the circuit is closed. Now what will happen? Current will flow. Where will current flow? Current will flow from the cell, from the positive of the cell, okay, like this. Should I consider current through the voltmeter? No need. So the current will flow like this, and that will flow through the resistor, then that will flow back to the through the cell like this. So that makes a complete closed path. No current through the voltmeter. You can assume voltmeter is not there. Now the voltmeter is connected across the terminal. So there is current flow. Current flows from cell. Current flows from the cell. And what does voltmeter read? Voltmeter reads potential difference across terminals. And what is that called? If there is no current, that voltage would have been called electromotive force, but if there is a current flowing, this is called terminal voltage. Terminal voltage V. So E and V are different. E is the voltage across the terminal when there is no current flowing. V is the voltage across the same terminal when there is a current flowing. So this voltmeter can measure any of that depending on the condition. Okay, Pakka? Watch out. What will that voltmeter measure? EMF. Repeat, EMF, electromotive force. Bapre, is it a force? It is not a force, it's all voltage. Be careful. Now what will it measure? Will it measure EMF? No, it is not measuring EMF now. Right now it's measuring terminal voltage. Adipoli. എന്താണ് ഇത് തമ്മിൽ വ്യത്യാസം? What is the relation between this? इसका relation क्या है? We need to study that. Relation between E, V and R. What is E? E electromotive force, V terminal voltage, R internal resistance. Now I'll tell you what this circuit represents. See, by this arrow mark and this letter V, what I mean to represent is that this is the voltage between this point and this point. I'm sorry. This technology is sometimes, technology is very fast, okay. By coming closer, this works fine. So this voltage, this means a potential difference. This means there is a difference between this point and this point. and this point actually is the same as the terminal of your cell. This is also terminal of your cell. So this voltage represents voltage across the terminals, and there is a current flowing because it's a closed path. So this is not EMF, it's terminal voltage. Okay. And how do we actually understand the relation between E, V and R? That's very simple. Let us use Ohm's law for that one. And I will just use the knowledge from the 10th standard. In 10th standard you studied that these two resistances are in series. They are in series. So what is the total resistance available? Total resistance must be equal to R plus R. And the potential difference is given by the cell. And the cell can give you a maximum of E. So the current in the circuit will be equal to the EMF divided by external resistance plus internal resistance. Current in the circuit, current from the cell equal to EMF of the cell divided by internal resistance plus external resistance. That is the current. Okay, once more, different angle. See, this is the positive terminal of the source, the cell, the battery. And here current flows from where? From this side to this side. So you know current always flows from higher potential to lower potential. So we will mark a positive here and negative here to show you this is at higher potential, this is at lower potential. That is why current flows from higher to lower, and that current flows back here. In every resistor, current flows only from higher to lower. See this, see how I marked plus minus plus minus. For the cell, plus minus is there by the symbol, you understand. How do I mark plus and minus in a resistor? See the direction of the current. See the direction of current. Suppose there is a resistor and current flows like this. Is it correct if I mark plus and minus? No. You should say, no, this is a madman's work. Current can never go from minus to plus. It should be plus to minus. Direction of the current. It should enter positive point, leave negative one. Enter positive, leave negative. So enter here positive, leave here negative. Enter here positive, leave here negative. Now in the previous classes I told you how potential is lost in a cell. I told you, okay, here there is a positive potential and there is a reduction in the potential. So we can say that you are giving a potential difference, you are giving a voltage E there. There is some energy, some potential lost in that resistance. This is nothing but I into R. Again something is lost here, that is again I into R. Then you come back to the same potential. The total potential difference will become E minus IR equal to 0. Or if you don't understand this, I can explain that in a different way. I can give you an example, something that we did in the last class. I told you like this. There is a resistor here. This has got 10 volt. This is say 5 ohm. Then what will happen? A current of 2 ampere will flow. This current will produce a drop of how much? 10 volt in this one, 2 into 5. Then we can see 10 voltage is given by the cell. And how much is taken by the cell? 10 voltage is taken by the cell. So given and taken, subtract, you get 0. Same idea here. What is given here? Given is E. How much is taken? I into R is taken. Also I into small r is taken. IR is taken, IR is taken. So this should be equal to the given equal to taken. So that gives you E minus IR equal to 0. Fine. Now I am going to rearrange this a bit. Okay. I write E minus IR, or I will write like this, E equal to IR plus IR. Now what is IR? What is I into R? I into R is the voltage across these points. Voltage across that point is nothing but voltage across these 2 points. See? So voltage across this point is what we call as V. So I should say IR is also equal to V. Focus. E equal to IR plus IR. Idea, given equal to taken. Okay. IR equal to V. V is the terminal voltage of the cell, which is also equal to voltage across this one because of the connection. Now this is IR, V. So therefore I can write E equal to V plus IR. E equal to V plus IR. Or from this I can write V equal to, what is V? V equal to E minus IR. The voltage available here is equal to EMF minus IR. And I'll tell you what this IR is. IR is the voltage lost inside cell. IR is the internal drop. You can also technically call it as internal drop. So when a cell is ready to give you EMF E, some voltage is lost inside, only the remaining thing is given to you. Okay, so IR is the voltage lost inside the cell, it's called internal drop. Terminal voltage is nothing but EMF minus internal drop. So you should write like this one, EMF minus internal drop. That's what we call the available one. In the last class I gave you two terms, one is created, another is available. E is the EMF created, but available is less. EMF minus internal drop is available. Okay. From there, so from here you get two equations. One you get V equal to E minus IR equation, terminal voltage, and the second one I equal to E by R plus R. This is the general relation between EMF V and R. So I'll repeat that one. We get an equation, terminal voltage is nothing but EMF minus internal drop. And we also know terminal voltage is nothing but I into R. And we know I is nothing but the EMF divided by R internal plus R external. These are the equations that you should know from this discussion. Okay. Let's go further. Let's go further. Why is it not coming? Yes. NCERT exercise. What is given? A battery of EMF 10 volt and internal resistance 3 ohm is connected to a resistor. If the current in the circuit is 0.5 ampere, what is the resistance of the resistor? What is the terminal voltage of the battery when the circuit is closed? A battery of EMF 10 volt. See how to handle this. Okay, how to handle this. A battery means it should be a set of cells. So you can draw 2 cells or 3 cells, okay, like this. This has got a 10 volt. EMF 10 volt means that EMF is given as 10 volt. Internal resistance 3 ohm. Where to put this internal resistance? That must be put here in series. This is 3 ohm. Is connected to a resistor. This is connected to a resistor means just like the previous diagram we did, we should connect like this. So this is the external resistance whose value is not given. Bad people, they did not give you the value. But they said something. There is a current is 0.5. How to mark current? This is the positive terminal. So current should go from positive to negative like this. This microphone wire is troubling me. It's troubling me. You know, if I step on this one, wire will cut and the current flow will stop and this voice will not reach there. So current is very important. So I have a closed circuit here, there is a current flowing. Okay. This current can be called as I. Now, what is the equation for current from the cell? Current from the cell is nothing but EMF divided by R internal plus R external. So R plus capital R is nothing but E divided by I, which is given E equal to 10 volt and I equal to 0.5 ampere. And this gives you 10 by 0.5 will give you 20 ohm. Internal is given 3 plus R. Solving this, you will get R is equal to 20 minus 3, 17 ohm. Simple. And they also ask it, what is the terminal voltage of the battery when the circuit is closed? The circuit is already closed. What is the equation for terminal voltage? Terminal voltage is given by E minus IR. What is that? E equal to 10 minus I equal to 0.5 into 3. So this gives you 10 minus 0.5 into 3 is 1.5 and that gives you 8.5 volt. This problem should tell you what's actually happening in a cell. The cell was creating 10 volt. Poor cell, it was creating 10 volt. But due to internal resistance, it lost 1.5 volt inside. So what is the internal drop here? How much is the internal drop? Internal drop is, I said, it's IR, and inside there is 1.5 volt lost. Only the remaining is available. The remaining is how much? 8.5. So they are telling that 10 volt can be created in the cell, but available is always 8.5 volt. With every cell in the world, this is the case. Even my mobile phone, on the mobile phone, it must be printed like 4.7 volt, but my mobile phone will never get it. There will be something lost inside. So is it good to have internal resistance or not? Is it good to have internal resistance or not? It is actually a matter of discussion. So we are coming to the conclusion section here. Relation between EB and R. Now you should notice this cell discharging. Cell discharging. When do we know that a cell is discharging? See this. Say there is a cell, there is a circuit. A cell is in a circuit, and if current is flowing out of the positive terminal, current flowing out of positive terminal, that's an important point. Current flowing out of positive terminal and enter or flow in enter negative terminal. When the current is flowing out of the positive terminal and enter negative terminal, cell is discharging, then this equation is applicable. V equal to E minus IR. Okay, in such cases we can say V will be less than E. In the previous question you saw E was 10, but your available voltage was only 8.5 flowing out. See, here again you can see current flows out of the positive but enter the negative. Clear. But when you can have your cell in different situations. Second one, what happens in this case? In this case, there is nothing connected here. So there is no current flowing. If there is no current flowing, then you will say the cell is open circuited. Cell is open circuited. If cell is open circuited, use the previous equation. Use the previous equation, V equal to E minus IR. V equal to E minus IR, but we know I equal to 0, which implies that V is equal to E. So when a cell is an open circuit, V equal to E and I is equal to 0. That's the second case. Third case, cell short circuited, open circuited and short circuit. In short circuit, what do we do? The terminals are directly connected by a wire, straight wire. Terminal is connected by a straight wire. Very important point, listen carefully. When terminals are directly connected, this point and this point is connected by a conducting wire, and we know in a conducting wire potential is same everywhere. So when it is connected like this one, this V terminal voltage will become 0. V will become 0 because this point A and this point B are at the same potential. A and B are at the same potential, that will become 0. But there is a current flowing. What is the current flowing in the circuit? We know equation for current was I equal to E by R internal plus R external. But what is R external? R external equal to 0. Short circuit means resistance is 0. Open circuit means resistance is infinity. So I equal to this thing. So but we have to substitute R equal to 0 because this is a short circuit. Therefore, what is I? I is equal to E divided by R. Compare this equation and this equation, then you can see that this current is more than that current because R is there, but here R is missing. Denominator become less, current become more. So this is the maximum current from the cell. This is called maximum current from the. How to find maximum current from a cell? Simply divide its EMF by its internal resistance. For example, suppose I have a cell 10 volt 1 ohm, 10 volt is the EMF, 1 ohm is internal. What is the maximum current from the cell? That is 10 by 1 ampere, 10 ampere. Okay, but this short circuit has a problem. The short circuit will produce a very large current, and the large current through the cell will heat up the cell, and this can eventually damage the cell. So you should prevent a short circuit. Never let any cell short circuit, because if you short circuit, the cells get damaged due to excessive heating. Okay, so I gave you a relation between EB and R under short circuit. Terminal voltage is 0. I told you why, and the maximum current is E by R. Okay, now there should be something for you. Work out this question, NCERT exercise 3.15. Secondary cell, 1.9 volt, large internal resistance 380 ohm. What maximum current can be drawn from the cell? EMF internal, you can find out. Can this start a car? To start a car, you need a very large current. Can this start a car? Answer me in the next class. Okay. Now, one more point. This I think I will discuss in the next class. But you can see, you can just go through this question and answer me in the next class. Now, one more point. When a cell is charging, what actually happens? I told you, you have a cell to be, where is it? Yeah, you have a cell to be charged. You use a charger, and charger will produce a current. And the charger will produce a current, and see the direction of the current. During charging, what is the direction of the current? During charging, the current will enter positive terminal and leave negative terminal. I should write here, during discharging, current enter where? Current leaves where? Current leaves positive, enter negative. But here current reversed. So you can say the current reversed. Therefore, in the equation V equal to E minus IR, this current is reversed. So you can put it as negative current. So what will happen? The current equation will become V equal to E plus I into R. This is for, I'll write here and I'll change this, because this is discharging E minus IR. See, when a cell is charging, V equal to E plus IR. When a cell is discharging, it is V equal to E minus IR. So the question comes, is V greater than E, or V less than E, or V equal to E? What are the answers for this? V can be greater than E when it is charging. V is less than E when it is discharging. V is equal to E if it is not doing charging or discharging, or if there is no current. Three relations. Fine. So this should be clearly understood. Relation between terminal voltage, etc. And there is a question here, 3.11. Please try to do that for the next class. Before the next class, we will discuss the answers in the next class. Till then, bye.